Welcome to One Window class. Myself Soumyajit. I'm going to discuss some important function and their graphs. Let me proceed to the first graph, that is fx equal to x. Now, before proceeding to the f of equal to x, let me tell you the graph of parallel to x-axis and parallel to y-axis. If graph is parallel to y-axis, then x equal to constant. You have to remember that means, like, if a graph parallel to x-axis, like if I draw the graph parallel to x-axis, the line of the equation is always x should be constant, because let's say it is 5, 0. Now in this point, let's say this is 1, so this will become 5, 1, and again here the point is 5, and here let's say -1, so 5, -1. So the graph of this is always x equal to constant, then it will become parallel to y-axis. I think this is clear. Now, same way, if a graph is parallel to y-axis, already we have drawn. For if it is parallel to x-axis means then y must be constant. Y must be constant. I have drawn the graph. If y equal to constant, then the graph is parallel to x-axis. Same way, if you take in one example, let's say if I draw a graph parallel to x-axis, then let's say this point is 0, 7. That means in this line everywhere the y coordinate is 7. Same if you take 1 here, so this will become 1, 7. If you take -1 here, this will become -1, 7. So everywhere the y coordinate is same, constant. So that is why y equal to constant, then the graph will become parallel to x-axis. Now let me show you y equal to x. That means f of x equal to x, then the graph of f of x equal to x. This is very easy to draw. Let's say this is 1 and this is 1. So the point 1, 1 will be here. Now if you take 2 here and the point 2 here, so the graph will become 2, 2. Whatever the value of x you will put, you will get the output same as you put in the input. So the graph will be like this. So this is the graph of y equal to x or f of x equal to x. You can draw using this is the linear graph, because degree is 1. So since degree is 1, so this is a linear graph. So linear graph will be always like a straight line. You have to remember this point. If graph is linear, function is linear, then graph will be, then equation will be like y equal to mx plus c in this format. Each variable and their degree or power is 1. Since degree and power is 1, so highest power will become degree. So for linear graph, it will be straight line. Now we'll proceed to the modulus function. Next graph of the function is modulus function. If it is y equal to mod x, you should remember the definition of y equal to mod x. See, in this part, if you increase this line, if you extend the line, this will become a straight line. But this negative part will not be there, because you are putting mod in the output. Whatever the output will become positive. Whatever input you give, the output will become positive. Let's say you are taking x equal to -3. Then what is mod x? Mod x will become mod of -3. So this will become mod of -3. So according to the definition of mod, it will become minus of -3. So this will become 3. So graph of, if you are putting mod x, it is -3 input. So you are getting positive as 3, comma, -3, comma, 3. Same way, if you put any point, let's say x2, so you will get 2 here at the same point. This is 2 and this is 3. These are the few important notes that I have provided here. Square root of x square. Square root of x square will become always mod x. That means square root of 4 will become 2 only. If you write plus minus 2, this is wrong. This will never become plus minus 2. It will always become 2. You should remember this point. Many of you do mistake in the paper. Square root of x square is always positive. It can never be negative. For same way, if you take one example, one other example, like square root of cos x square, it will become mod cos x, because cos, we will see in the graph, cos x graph, that time I will explain this, why it is becoming like this. Now if you take mod of x equal to, if you take mod x less than or equal to a, then x must lie between a and minus a. The reason behind, let's say you are telling mod x less than 2, mod x less than 2. That means you can take the value less than 2, that is fine. But what if you are taking less than -2? If you are taking less than -2, let's say if you are taking less than -2, if you take -3, so this will become mod of -3 will become 3, which is greater than 2. But in the inequality, it says you are taking mod x less than 2. In the inequality, you are taking less than 2. So you cannot take less than -2 in mod x, because mod of any value will become positive. Mod of any negative value, negative numbers will become positive. So this is the reason you said take the value of x in between -a and a. If it is mod x is greater than a, then you should take the value between less than -a of x. X is less than -a and x is greater than or equal to a. And this is very important property, that is mod of x plus y, x plus or x minus y, it will become mod of x plus mod of y, and it will be less than or equal to, it will become like this way. So these are the properties you have to remember. Now I will go to another function, that is greatest integer of x. Now to draw this greatest integer function, you should remember, let me teach you some tips. Greatest integer of 3.5 will become 3, because if you see the graph of greatest integer function, this is 1 2 3. Before 3, the graph is taking only after 3. If you are taking more than value 3, the graph is becoming straight line on y equal to 3. Same way, if you are taking greatest integer of 3.9, this will also become 3. Greatest integer of minus 3.5 if you take, it will be closed left. It is, if you are taking minus 3.5, so minus 3.5, that means this is minus 3, minus 3.5. So the graph is coming minus 4. It will come minus 4. That right? Okay. If you take minus 7.5, so this will become minus 8. This way you can plot the graph in the graph paper and you will get like this kind of graph. And this is the graph you have to remember. This greatest integer function is known as well floor function. The property of, I have written some important property of greatest integer function. That is, greatest integer of minus x will become minus of greatest integer x minus 1 if x is not integer. If x is not integer, if x is integer, for all integer point of x, like let's say greatest integer of 7 minus 7 will also become minus 7. Greatest integer 7 will become 7. For all integer points, the greatest integer will become the same. For minus 3 will become minus 3. Minus 7 will become minus 7. For greatest integer of 7, that will become 7. And this last is very important. For n belongs to n, then greatest integer of x plus 1 by n, x plus 2 by n, x plus n minus 1 by n will become n x greatest integer. Do one thing, you can prove this in home. Prove this in your home and send me your solution. I will check your solution. Let's say this is your homework to prove. In the next video, I will show you this proof. You can follow me in the next video. This is very important graph, very important property of greatest integer in limit, in many calculus, in many problems in calculus will use this formula. So remember this formula. For n belongs, if it is n belongs to n, then greatest integer of x plus greatest integer of 1 by n, it will become n x greatest integer. Right? Okay. Now we'll proceed to the floor function. We will proceed to the fractional part. Fractional part. See, we have just learned greatest integer of x, how we can solve or how we can calculate. Now let's say I'm taking 3.5. I'm taking 3.5. So for x, I'm taking 3.5. You put 3.5 minus greatest integer of 3.5. So this will become 3.5 minus 3.5 minus 3. So this will become 0.5. Same way, if you calculate, let's say minus 3.9, minus 3.59 of fractional part, minus 3.9. So this will become minus 3.9 because x is, you whatever the x will write minus 3.9 and then minus greatest integer of minus 3.9. So this will become minus 3.9 and greatest integer of minus 3.9 is nothing but minus 4. So minus of minus 4, this will become 4 minus 3.9. So this will become 0.1. So whatever the value you are taking, fractional part, it will always become less than 1 and greater than 0. Why? Because now if you take any integer points, let's say x, greatest integer of x, I'm taking fractional part of 3. fractional part of 3 or fractional part of, I'm taking k. So this will become k minus greatest integer of k. Just before I told you, just before before sometime, I just told you greatest integer of any integer value, integer points, you will get integer itself. Same way you get here k minus k, because I told you k belongs to integer. I told you k belongs to integer. So k minus k will become 0. So for any point, integer points, for any integer point, the greatest integer of any integer point will become 0. And we have checked the value of this. So we can easily conclude the fractional part of this will become, let's say this is 1, 2, 3, minus 1, minus 2, minus 3. You can plot in the graph, take any random points between 0 and 1. You will get like this straight line graph. This is the way you should remember. You should remember this. This is very important graph. Now let me proceed to the exponential graph. Now to do this graph, we need to just remember this, how we can approach for a to the power x when a greater than 1. Now let's say a to the power x. If it is x less than 0, now I took a greater than 1, right? If x is less than 0, let's say x is minus 5. What is x is minus 5? I took a greater than 1. Let me take this 2. 2 to the power minus 5. This will become 1 by 2 to the power 5. Now, if you take, since x is less than 0, so you take 2 to the power, now I am taking a as 2. For this, I am taking a as 2. And now decrease the graph. Decrease the graph of, decrease the value of x, so that x equal to, let's say, minus 10. I'm taking, that means 2 to the power minus 10. So this will become 1 by 2 to the power 10. So if you go on decreasing the value of x, it will become tends to 0. So this will become less than 1. Because 1 by 2 to the power 5 is always less than 1. This is 1 by 2, always less than 1. But this will tend to 0. So the graph is like this, tend to 0. This is the point. This is 0, 1. So graph is below 1, because we got it is less than 1. Now what if x equal to 0? Then a to the power 0 is 1. And if it is x is greater than 0, then what it's becoming? If it is x greater than 0, I am taking, for example, I am taking a equal to 2 and x greater than 0. Then the graph, let's see. Now 2 to the power 5. So this is 32, which is greater than 1. Again 2 to the power 10. Again it is greater than 1. So the graph will increase to infinity. So this the way it should go, right? So x greater than 0, then it is greater than 1. So this is the way you should approach the graph of exponential function. Same way you can draw. This will be completely reverse, because the value of a is fraction, 0 and 1. Let's say I'm taking a equal to 1 by 2. So this will become 2 to the power minus 1, right? 2 to the power minus 1. And now see a to the power x equal to. Now if you take x greater than 0, that means 2 to the power negative. Whatever you are taking, 2 to the x is greater than 0, then the function y will become 2 to the power negative. 2 to the power negative means it will become less than 1, right? 2 to the power negative, that means 1 by 2 to the power 1 by 2 to the power positive. That means it is less than 1. Now x equal to 0 means 1. X equal to less than 0. If it is x less than 0, then it will become positive 1, because now the a itself 2 to the power negative. Now again a to the power x you are taking, where x is negative, so this will become 2 to the power positive, which is greater than 1. So for this graph 0, 1, 0, 1, for this x, when x, because this part is the x-axis, so right side of the origin x is greater than 0, so the graph is decreasing, and here graph is increasing to infinity, right? So these are the way, this is the way you should remember the graph of exponential function. Now I will go to the logarithm function. Now next part is logarithm function. This is also another very important graph that you have to remember always. In some of the physics part also you need log x and exponential graph, so you should remember these two graphs, very important for solving any difficult problems. Now let me go to the logarithmic function. Let me show you how to calculate this function. Now first is a is greater than 1. Let me take log x base a. Now I will calculate x. If obviously it is very obvious that x should be always greater than 0, correct? Greater than 0. Now if it is less than 1, now let's say x is less than 1, because we know graph will cut here 1 comma 0, because log 1 we know log 1 is 0, so the graph will cut x-axis at 0, 1. Now if x is less than 1, now let me check if x is less than 1. Let me check x is less than 1 and it is 2. So if it is x less than 1, I have taken a as 2. I have taken one example a as 2, and I am taking for one example as 1 by 2. So this will become log 2 power minus 1 base 2. So this will become minus log 2 base 2. So this will become minus 1. So for x equal to half, you are getting the value as minus 1, right? So the graph is negative, correct? So graph is negative. If x equal to 1, then graph is 0. Then x equal to greater than 1, take another example. Let me show you. Greater than 1, and I have already considered the value of a as 2. So let me, for easy to understand, like I'm taking 4 exponents of 2, so that we can easily solve the log. So this is 2 log 2 base 2. So this will become 2, which is greater than 1. So it will become greater than 1. Or let's say it is positive, because the graph will be above x-axis. So the graph is like this, right? Same way we should approach this function. Same way we can approach, just take the reverse. In this part, this is same, will become 1 comma 0. If you are taking x is less than 1, the graph will become positive, because a itself you are taking smaller than 1. So this is the graph. This is the graph of y equal to log x base a, when a will lie between 0 and 1. And always remember, x should be greater than 0. You cannot consider the value x negative. You cannot take the value x as negative. This is the property of log. Now I will go to the next graph, that is y equal to x square. This is the parabolic graph that you have studied in quadratic equation. Y equal to ax square plus bx plus c, whose vertex is minus b by 2a, comma, minus d by 4a. What is d? D is b square minus 4ac. This is the extreme values. This is the extreme values of quadratic equation. That means the graph will become either upward or downward of, if it is power of x is 2, then graph will become either upward or downward. If graph of x square or y equal to x square, the graph will become like this way. This is vertex is 0, 0. From 0, 0, it will start. And for y equal to square root of x, the graph will become like this. Because if you take for 1, it will become 1. For 4, you will get 2. So the graph will not increase exponentially. It will increase slowly. And you will never get in the negative part graph, because square root of x square, we have studied square root of x square is always positive in the modulus function. In this, we have studied square root of x. 1 minute, let me show you. We have already discussed square root of x square is always positive. So square root of x, in the square root of x graph, you will not get negative part, because y will always become positive, right? Okay, now we'll go to some basic trigonometric function and their graph. This is y equal to sin x graph. You know, graph sin x graph will take maximum as 1, because sin x always lie between 1 and -1. So the graph will never go upward than 1. It can never be greater than 1, or it can never be less than 1. It can never be less than -1. Right? These are the points that I have plotted. For pi by 2, it will become 1, because sin pi by 2 is 1. For sin pi, it will become 0. Sin 0 will become 0. So the graph will become like this for sin. And same way, for the cos graph also, you have to remember, for the graph of cos x graph, it will, for cos, this is y equal to cos x graph. For same thing as sine, the graph of a cos function is always lies between 1 and -1, right? So this is 0, 1, because cos 0 is 1. Same way cos pi is -1, that we know, cos minus of pi is -1, cos of -2 pi is 1. And this point is nothing but pi by 2, 0. And this is also minus pi by 2, 0. This you have to remember for cos function and tan function. And also that this is the last graph, that is tan function. This is y equal to tan x. We know tan pi by 2 is infinity. So you see here, in 0, this will become 0, because tan 0 is 0. and this is nothing but x equal to pi by 2, and this is nothing but x equal to 3 pi by 2. This is x equal to minus pi by 2, and this is x equal to minus 3 pi by 2, right? This is the graph of tan. Because if you take in the first quadrant, if you see in the first quadrant, tan is positive. So 0 to pi by 2, because this point is pi by 2 comma 0. So in pi by 2, it will become infinity. It will not touch this pi by 2 graph, pi by 2 line. And same way in this minus pi by 2 line, it will also not touch. And minus pi will become 0, because if you consider this is minus pi by 2, and this is minus pi comma 0. This is minus pi comma 0. So greater than, less than minus pi, because if you go like this way, this will become 0 minus pi by 2. This is minus pi. So minus pi by 2 pi will become positive. Greater than pi will become negative, because this is the quadrant of sine. So in third quadrant, this is the way you should remember for 10x. So these are the graph you have to remember before I upload the basic transformation or linear or graphical transformation. I will upload in tomorrow. Before that, you just remember these basic graphs, so that graphical transformation you will be able to understand very easily, right? Thank you.